A farmer who owns 2 goats, 1 cow, and 1 horse wishes to create 3 congruent adjacent rectangular regions in which to keep his animals. He has a total of 200 feet of fencing to create the rectangular adjacent regions. Let X represent the length of one rectangular region and let Y represent the width. Whether you choose to view this as the length and put an X, or you choose this to be the length and put an X, it doesn't matter as long as you are consistent throughout the problem. Let's go on to part B. So we now are going to express the width of each rectangular region in terms of X. So I'm going to come back here because I want to make it consistent. I'm going to write in where the variables belong. I know that 200 feet of fencing is used to create this. So 200 equals, there is a total of 6 X's and a total of 4 Y's. Remember, X represents the length and Y represents the width. So we want to express the width. That means I want to solve for Y or isolate the Y in terms of X. What does that mean? My final answer is going to look like Y equals some expression, and in this expression you will only see the variable X with other numbers. So how do I isolate the Y? I'm going to start by subtracting 6X to the other side. 200 subtract 6X equals 4Y, dividing by 4, and I am not requiring you to reduce this. I am not requiring you to reduce this. I've just expressed the width of each rectangle in terms of X. Moving forward, now we're going to express the combined area. The key is not just the area, it's the combined of all 3. As a reminder, this length is represented by the variable X because I'm keeping it consistent, and this length is represented by Y. So when I first just think of how do I determine the area of a rectangle is length times width. Now this particular rectangle, the area would be X times Y. When it says combined, we are now creating a function. This is a function of the area in terms of X. So on this side, I only want to see the variable X. Now at this point, I've only represented the area of one rectangle. I want the combined 3, so there's 3 of them. This is not wrong, it's just the first step. How do I rewrite this only involving the variable X? Well, I'm going to rewrite it, and I'm going to go back to the last step. I know that Y is equivalent to 200 subtract 6X over 4. This represents the combined area of all 3 regions. Another way to think of this is I have 3 groups of this. 3 groups. So this is X times Y, X times Y, X times Y. 3 of them combined to give you 3XY. What is the domain? Okay, domain means what is my input. So the first thing we're going to do is, again, if you have not done so, please do second plus 7, 1, 2. I want to type in this formula representing the combined area. Now when I do so 3x, because we have 3 of these, and now I have a fraction here. I'm going to be safe and put an extra parenthesis around the numerator. So 200 subtract 6x is going to have an extra parenthesis. When I look at this shape, remember the input represents the length. This has to be greater than 0. If there is no length to x, I no longer have this shape. We would just have these vertical lines and no shape to create these corrals for animals. So this x has to be greater than 0. So I'm going to put down 0 as a minimum, but I know it can never actually equal 0. And then I'm just going to choose an arbitrary number for x maximum, and then I will either increase or decrease after looking at the picture. So let's start by doing 25. So 0 to 25 and hit zoom fit, which is zoom 0. I want to see the entire parabola. I can't see that. I've only gone out to 25. I'm going to try 50. Zoom fit. I can see the entire parabola. Now, in order to figure out the domain, I need to first figure out what are the zeros. It appears like one of the zeros is 0, and I can verify that by hitting Second, calculate value and type it in 0. Yes, 0 is one of the domains. I'm going to come back to it in a little bit. Then I want to know what is this value. And there's a couple ways we can do it. One way is the initial way we learned how to use the tool in the calculator for zeros. So left bound means above. I am going to demonstrate both ways in case you forgot. So I'm hitting above and enter, below and enter, and back to it. So I can see the other one is going to be 33 and a third. Thumbs up or thumbs down if you have the same. 33 and a third? Okay. I also want to reiterate the way that I prefer to find the zeros. It went from 0 to 50 is like this. Second, calculate 0. I choose one value over here like 20. This goes out to 50. I choose another number way out there like 40. And then it's in between. I press enter. We get the exact same answer. So the domain. This is the maximum value for this length. It can go all the way out to 33 and a third feet. It can include that. It will never include 0 because this length must be greater than 0. You could write it in this form, or we could write it like this. On here to the next part. Determine the combined area when the length of one region is 20. So when they're saying when this length is 20, what is the combined area? So we're going to come up here and go second calculate value and type in 20. This is the area. How do I correctly write it? 1,200 feet squared. That is the area when the length is 20. This is what I need to see. The formula that I started with looked like this. It looked like this. We had 3 equivalent rectangles, and then we took out the y because we could only have one variable, and we replaced it with an expression, equivalent expression for y. They're saying, what is the maximum area? So as I look at this picture, I want to know what is the maximum. How do I achieve that? Second, calculate maximum. I'm choosing a value over here. For instance, like 15, I'm choosing a value over here, maybe 30, and then pressing enter in between. This is the answer. What does this mean? This is the maximum area of the 3 combined rectangular regions, and that occurs when x, or the length, is equivalent to 16.6 repeating. So what is the maximum area? 1,250 feet squared. Next question. Using that information, when we have a maximum area, determine the dimensions. So, again, dimensions look like this. There's 3 of these, and we're talking about the dimensions of just one of these rectangular regions. We know they're all equivalent in size. Well, we can see when we hit this maximum, we can see that x is equivalent to 16.6 repeating feet. We need to know what is y, representing the width. There are 2 ways to do this, and you're going to have to replicate this in the next problem. Please pay attention. One way that I prefer is this represents the combined area of all 3. So if I take this and divide it by 3, I know that the maximum area of one region would be 416.6 repeating. That's the maximum area of one region. Now that occurs when we have the length times the width, when I can see that this length is 16.6 repeating. So 16.6 repeating, I don't know the width, is equal to 14.6 repeating. So here we go. I have 416.6 repeating divided by 16.6 repeating, and I can see W is equal to 25. So I have a width of 25 feet and a length of 16.6 repeating, and then I get a maximum area of 1250. That's my preferred method. Here's another method that we could use. The other method is that I could use this formula right here. Ultimately, I'm trying to find what is y. And we know y is equal to 200 subtract 6x over 4. So what I could do is type in 200 subtract 6 times, well, we know the x is 16.6 repeating, divided by 4. and we get the exact same answer of 25. It is your choice in how you go about doing that. Okay, talk to your partner. You have a test question like this. There's a difference between a maximum of an A or a B. We're going to test you on another one like this today before we do the next problem. So talk to your partner right now. Go. Remember, as you get into upper level math, time is often the problem for students. Time is often the problem.